whole thing again.
Yeah, yep, act like we're doing something. No. Yeah. Okay, we're live now, so.
All right, perfect. Ready for the quiz then?
Yeah.
All right. True and true. All right, we're rounding to 3 decimal places again, and don't round until the calculation is complete.
Awesome.
You ready for number 3?
Yep, I'm ready.
Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Oh, so we don't have to do any work here, just plug it into the applet?
Yeah, that's what it looks like.
Sweet.
That's nice. And then we'll just shade to the left and to the right?
I believe so. I'm going to read that again just to make sure. So to the right of the positive and left of the negative. Yep, so we shade the edges.
Okay. Well, I got 0.175.
Yep, that's what I have as well.
Okay. Okay. Are you ready for number 4?
Yeah.
Okay. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population? Okay. Would that be B?
That's what I'm thinking. I was just trying to go over mine. It seemed like all of the distribution of the sample means were smaller.
Yeah, because if you just have one, you could have like an outlier that's away from the mean, I guess.
Yeah, that's a good point. Okay, yep, B sounds good to me. And number 5, which of the following results implies that the spread in X bar decreases as the sample size increases? Spread decreases. This be, oh, it's one of the last 2, right?
Yeah, isn't it the central limit theorem?
I can't remember. Let me go back to my notes. I'm sure that's right if that's what you're thinking.
So my notes say the sample size, if the sample size is large, then the central limit theorem implies that the sample mean is normally distributed. Is that what that's talking about?
Yeah, I think you're right.
Actually,
So you still think it's central limit theorem?
I mean, that's the one that makes most sense to me right now.
Yeah.
We know it's the last 2, so like,
Right.
we could just go with it.
50-50 shot there.
Yeah.
Okay, so use the following. Answer the next 4 questions. Sweet.
Scores on the quantitative portion of the GRE are approximately normally distributed with the mean, I guess the population mean at 150.8 and standard deviation of 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? So would this just be the formula we learned the other day, like with the sample, then you get the sample and then you subtract the population, and then you divide that by the standard deviation.
I'm pretty sure that's what it is, yeah. So 160 minus 158 divided by 8.8.
Yeah, I think so.
I got 3 decimal places. 1.045 for that.
That's what I got too.
Okay. I'm pretty sure that's the right formula.
Okay.
What is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? So I think this is what we've been doing today.
Okay. So that 1.045, would we just plug that into the applet and then shade?
Well, I was just trying to think, because we'd have to find the z-score, we'd have to divide the standard deviation by the sample size, but we don't have that. So maybe that's not what we would do. Maybe we just plug in the z-score like you were saying, instead of...
No. But she did earn a score of 160.
Oh, yeah, you're right. I was just over complicating it. So I think we just,
Oh, no.
I think that's our z-score that we plug in.
Yeah?
I think so.
Okay. Okay.
We're looking for above that. Yeah. Did you get 0.1480?
Yeah.
Okay.
1,480?
Yeah, I guess 0.148.
1,480, yeah. That makes sense. Awesome. Okay. Are you good for number 8?
Yeah.
Alrighty. Random sample of 5 students was selected to take the GRE. The scores are, there's 5 scores.
Oh, we have to figure out the standard deviation, don't we?
Will we need to on these? Around this one?
What is the z-score? I think so. Because
Okay.
it doesn't give us the standard deviation, which we need in the formula.
Dang it.
Man, this is a long process.
I'm rusty on these things because it's been a few days.
Yeah. I just want to make sure I got this. Did you get 800 for the sum of all 5 of those?
Yep. Okay.
Okay. Perfect.
And so the mean would be 160. Is that?
Yeah. 160.
Okay, and then from there we plug that into the formula, but we need the standard deviation, right? And that's what you're talking about.
Right. So now what we do is we subtract the that average from each of those individual scores.
Okay.
And then we square those results.
Gotcha. Oh yeah, there's that pesky formula.
Uh-huh. Oh, yeah.
So you subtract the from each one of those.
Yep. So it would be like for the second one, 175 minus 160.
Okay. Gotcha.
And then we
And then
square
sorry.
each of those individually.
So when are you planning on taking the test?
Does it open up tomorrow?
Yeah, either that or on Ireland, on the calendar, it said it opened up today.
Oh, okay.
I was confused, but I think it's open until Wednesday.
Oh, okay. I'm probably actually going to take it tomorrow, so I don't have to worry about it.
That's a good idea.
Yeah.
Get it out of the way.
Yeah, this is my mind's going blank here. Is a negative number squared make a positive number?
Yeah, it does.
Okay. Perfect.
Okay, so once each of those numbers are squared, where do we go from there?
Then you add up all of those.
Okay.
And then kind of know what to do, but I have to look back at my notes here.
Okay. I need to go over that again.
Oh, I almost missed a step. Yep, so we add those up and then divide by 1 less the total number of things there are.
Once you added those up, did you get 404?
Yeah, I did.
Okay.
And then we would divide that by 4, which would give us 101. And then I think we square root that.
All right. Sounds good. And then, did you get 10.05?
Yeah. Alrighty. So, all that work for the standard deviation. No, I gotta remember what the problem is. What is the z-score for those? Okay. So, we've got
So is this just a regular z-score formula?
So I'm trying to think.
Okay.
Would the mean just be just the mean of those scores right there?
I believe so.
Okay.
Yeah. Which was, what was our mean again?
160.
Okay, yeah. Yeah. We need to find the population mean too, then, right?
That is 150.8. At least that's what it says in the explanation up top.
Okay.
Oh, wait a second. I'm so sorry if we just had to do all that work for nothing.
Hey, it was good practice. Don't
Oh,
worry.
man. Is the standard deviation 8.8?
Is that what it says up there?
Because
If so,
that is one there. Oh, man. Well,
yeah. Hey,
darn.
good. I'm sorry, I didn't remember that.
Oh, no, you're good. But, hey, at least it was a good review.
That's true.
Like you
It was good
said.
practice. Okay.
Well, I'm a goofball. Okay, so 8.8 divided by, what was it, 5? What was the sample size?
That was a sample size, yeah.
Okay. Gosh.
All right. Did you get 2.338 by chance?
Yes, I did.
Awesome.
And this question is asking for the z-score, so 2.338. We could have been done with the quiz by now if I didn't beef that up.
No, hey, you're.
All right.
It's not your fault. I should have been paying attention too. So.
So, what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So, I think here we just enter in the z-score into the app. Does that sound right to you?
Yeah, and then just get like the positive side, I guess.
Yeah, I think so.
That makes sense.
So for that, I have 0.0097.
Did you plug the 2.338 in for the area or the z-score?
The z-score.
I'm doing something else. I just get a probability of 0. So 2.338, right?
Yeah, for the positive z-score on the right. That's really weird.
Yeah. I'm using the one from assignment 4 because that's the only one I could find, but then I realized...
That's same, actually.
Oh, really?
Yeah. And you shaded in the right side?
Oh, man. I didn't shade in anywhere, that's why.
Okay.
Thank you. So 0.0097?
Yeah, that's what I have.
Okay, good. I'm the goofball. I'm the one. That's right. So it was question 9?
Yeah, that was question 9.
And it was 0.097?
0.0097.
Right. So do you think that would be approximately normal? Is that what you think?
Um,
I'll let you
oh,
think
I
through it.
completely skipped over that question. I didn't even see that for some reason.
Oh, you're good. That
Uh,
question came.
Suppose the mean was left skewed. No sample. Yeah, I would say it's approximately normal. That's a pretty big number.
Yeah, that's what I was thinking. Yeah.
So what is the mean of the distribution of the sample means, sampling distribution, for all possible sample sizes of size 81 that could be drawn from the parent population?
Okay.
It's a very wordy question there.
Yeah. What is the mean of the distribution? So basically, what is the mean of the means?
Probably,
All the possible.
which is 3.5, right?
Is that our mean?
I think so.
Okay. Yeah, that makes sense because the mean of the mean, it's just the mean, right?
Yeah, I think so. If this is what it's asking, or if it's what I think it's asking.
Yeah.
And then
That makes sense.
standard deviation. Okay, that is that 0.7?
Good question.
What was that?
Good question. Is that what we had written down for standard deviation previously, or how did you find that answer?
I just looked at the standard deviation at the top.
Okay.
But now that I think about it,
I mean, that could be correct. I'm not sure.
I think I was just thinking that because the last one was
Just
straight from
mhm.
there, but it could be where you have to figure it out.
Okay.
I don't know what to do there.
Yeah, I don't either. I mean, we could just try plugging in the standard deviation that's given, because
Okay.
it did give us one, right? So
Yeah, 0.7.
that makes sense.
All right. What is the probability that the mean GPA will be less than 3.3? Okay. Maybe I have to do some plugging in here.
Yeah. Do you remember what the population mean was?
It is 3.5.
Okay, thank you. So I'm just curious. Did you lay out your equation 3.3 minus 3.5 divided by 0.7 which is also divided by the square root of 81.
Yep. And for the z-score, I got minus 2.571.
Okay. Just give me 1 second. I'll see if I can get that same answer. So where did you guys lose your keys at?
We don't know. We think. Sasha, did you drive home with them, or I mean, did you drive from work with the keys or the spare keys?
From work? Okay.
Spare keys.
Are you done?
No, he was just asking. It was either at work or in
I
the
couldn't find them at work.
organ practice room that my wife was in, or somewhere along the path.
All right.
Yeah.
Well, if you give me a description of them later, I'll keep an eye out for them in the lost and found.
Okay, I'll do that.
But
Nice.
yeah, I got the same answer though.
Okay.
Does your wife play the organ?
She does, yeah.
Really cool. That looks so hard.
I know. She's played the piano for most of her life
In America.
in America. And she started learning the organ. She started taking organ classes up here at campus. I think this is her 3rd semester doing it.
Wow.
4th semester.
Gotcha. Is it hard to use, I mean, is it hard to use your feet and your hands at the same time?
What do you think, Sasha? Is it hard to use your feet and your hands at the same time playing the organ?
She's finally only getting the hang of it 4 semesters later.
Yeah. She said she's just now getting the hang of it 4 semesters later.
Wow.
But she's the ward organist, so she has lots of practice.
I bet that's a hard calling. I bet it's fun.
Yeah. And our music coordinator usually doesn't get her the hymns until a few days before Sunday. Just
Really, so, oh yeah, she has to practice like last minute.
Exactly.
Oh.
Exactly. So on the applet for the area less than that z-score, I got 0.0051.
So I'm just plugging it in. Sorry.
You know, you're good.
That's what I got. Perfect.
Great.
So what was it again?
Circle that z-score, just in case that's the actual one they were asking for in the previous question. You can go right back to it.
Okay. That's a good idea.
Okay.
So you got 0.0101. Is that what you got?
Oh, I did not. I got 0.0051.
0051. Okay.
Yeah.
Oh, okay. I got it now. I have both sides highlighted.
Oh, okay. Gotcha. So what is the probability that the mean for a GPA for 81 randomly selected students will be greater than 3.3? So now we just shade above that z-score. And I get 0.995.
Me too.
Makes sense because they should equal 1 together.
It's cool when things like that click.
Yeah, definitely.
All right, the United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after a tragic boating accident. The standard deviation of passengers the passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. Sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was the observed in this sample.
So does that mean when we get to the applet, we would shade the left and the right sides?
That's what I assume.
Okay.
Makes
Sounds
sense.
good. Alrighty. And now the sample mean 176 or 177.6 pounds. Is that the X with the bar over it part of the equation?
I think so, yeah. The X with the bar over, I think that's the sample mean.
Okay, and then 185 is the mean?
Yeah.
Okay. Alrighty. So for the equation, I have 177.6 minus 185 over 62.7 over the square root of 48. Does that sound like what you have?
Yeah. Yes. Isn't the, I got the standard deviation being 26.7.
Oh
Is that what you
my
got?
gosh, I'm dyslexic. Holy cow.
Oh, no, you're good. You're good.
26.7, not 62. 96.7. There we go. Divided by the square root of 48.
Yeah, that was.
Good thing you got that. All right. And for the z-score, did you get minus 1.920?
Yep, that's what I got.
Awesome.
Probably. So do we just plug that z-score in and then shade to the left and then to the right?
I believe so.
Okay. So I got 0.0549.
That's what I have as well. Okay, so I can go ahead and submit mine here.
Alrighty.
Ready for it. Submit. Moment of truth. Okay, we missed 2.
Okay.
Let's see.
Hopefully it wasn't the first 2.
It was not. We missed question number 5. Okay, so it must be the other law. The law of large numbers.
That's nice.
Okay, and number 12. Yep, okay, there was that one. The standard deviation.
Oh, okay.
Guess it
So we need
was asking for negative 2.571. All right, let me get back into the quiz.
Let me know when you're ready, and I'll start giving you the answers.
True. Okay, number 3.
0.175.
Okay.
B, so the distribution of the sample means.
The number 5 is the law of large numbers.
Yep.
Correct answer there. And number 6.
1.045.
Number 7.
0.148.
Number 8.
2.338.
9.
0.0097.
10. Was that approximately normal?
Yeah,
Okay. 11.
3.5.
And 12 is
Negative 2. Yeah, you got it.
Okay. 13.
0.0051.
14.
0.995.
And 15.
0.0549.
Okay, sounds good.
Okay, I'll submit mine and see how it goes.
Sweet.
I still missed 12.
Really?
Yeah, maybe I just put it in wrong.
Huh.
What answer do you have?
Negative 2.571.
Yeah. Yeah,
Is that
that's
what
what I
you had?
had. Yeah.
Okay. What is the standard deviation of the sample means? We put 0.7. Let me try that formula again.
Okay. I'll try it too.
Huh. Don't know if I can do the formula though, because there's no mean to subtract the population mean. Is there? 3.5. 7. How do we get? Where do we get 3.3 from?
Good question. What are you looking at right now?
Number 12. I'm just trying to figure out how I got minus 2.571.
Yeah. Yeah, I don't remember.
I have 3.3 minus 3.5 divided by 0.7 divided by square root of 81.
Yeah, I have that written down as well. But what were
I
you
don't know
saying?
where I got 3.3 from though.
Good question. Oh,
What is the standard deviation of the distribution of the sample mean sample distribution for all possible samples of size 81 that could be drawn from the parent population.
Yeah, I don't know. I don't know whether to open my quiz again and throw all the answers in again, or if I should be content with that score.
Yeah.
Probably not.
It's not minus 2.57. I think I got 3.3. The next question, number 13, has 3.3 in it. I don't know if that's got it from or not.
So it could be 3.3.
Well, that's what I used for the
Oh yeah.
mean of the samples.
Gotcha.
Gotta plug my computer in here really quickly.
Yeah, you're good. Don't worry. Okay, I'm gonna open my quiz back up. Could I get the answers from you?
Yeah.
Again, and then I guess we could try and figure it out. Sorry to create more of a hassle here.
Oh, no, you're good. I'm just really confused by number 12.
I hear you. I don't really know where to start.
Yeah.
All right, number 3.
0.175.
4 is B, right?
Yep.
5, the law of large numbers.
Uh-huh.
All right, 6.
1.045.
7.
0.148.
All right, the next one.
2.338.
9.
0.0097.
'Approximately normal.
Correct.
Right?
Yep.
11.
3.5.
And then 12, we're trying to figure it out. 13.
0.0051.
14.
0.995.
15.
0.0549.
0.0549.
Yes.
All right. Pesky number 12.
What is the standard deviation of the distribution of sample means? Sampling distribution for all possible samples of size 81 that could be drawn from the parent population. I wonder if I just typed in 0.7 wrong, because I was just looking at question 11. It's worded the same way, just switched out with the terms.
Okay. So, I think it could possibly just be 0.7.
Could be. I'm going to go ahead and try that again and just have to be satisfied with whether or not.
Okay. Okay.
If that sounds like a good plan to you.
I mean, I really don't know where to start.
Yeah. That's the only thing I could see.
Yeah.
All right, here we go. Yeah, it wasn't 0.7.
Oh, I'm sorry, man.
All right, but hey, we only got one wrong there. I'm happy
Yeah,
with
yeah,
it still.
yeah, no, that's good. You did it. I'll just go in and throw that in there too. And,
The only way that I know of to find the standard deviation is to either have all the observation or have the sample median mean to subtract from the population mean.
yeah. Yeah.
I don't get it.
Me neither.
Oh well, what's done is done.
That's right. Well, cool. We still did pretty good, I
Yeah,
think.
no complaints about a 94.
Yeah. Yeah, that's true. So I think we're good there.
Awesome.
I will look out for your guys' keys tomorrow if you tell me what they look
Okay.
like.
What was that?
If you tell me what they look like.
All right, I'll shoot you a text.
Awesome. Okay, sounds good.
All righty, thank you.
Well, I'll talk to you later. I'll post the link this time.
Okay, sounds good. Have a good weekend.
Bye. You too.